It's time to learn some science. Hey everyone, I'm back in my basement. It's finally done. Woo! A little chilly down here tonight, so I got my hat on and we're ready to go. So, we've been looking at erosion and we've been reviewing its concepts as of late. So, I'm going to continue that review using a few animations. And this first animation shows you kind of a desert region and how wind is going to affect this desert region. So let's click play here and see what happens. So what we have is an animation showing you basically wind being blown in this direction, okay, and moving fine sediments across the screen here or across the landscape. And these fine sediments, when they're moved like that in a desert area, we call that deflation. All right. And as all this sediment deflates to another area, like the sand dunes over here, kilometers away, go figure. All right. Basically, we are left with a hard surface with these larger rocks lying around. And this is what we call desert pavement. And you can see here in this picture, this place in southeast Morocco, where the wind has taken all this fine sediment by the process of deflation and has moved it into the sand dune areas several kilometers away. Okay. Now let's take a look at the sand dunes. All right. So if we run the animation again and we follow all this sediment, okay, and we go way down this way, we come into the area of the sand dunes. This is where all of this fine sediment gathers. And this fine sand and sediment basically starts to form what we call sand dunes. And what you see on a sand dune is you'll see on one side of it where the wind is coming from, we call this the windward slope. All right. And its gradient is not nearly as great as the backside. The backside's slope is quite a bit larger. Okay. The gradient is steeper. And the reason is because the wind no longer carries these particles when they reach the side and they fall due to the force of gravity and it forms a steeper side. All right. And we call this the slip face. Okay. So that's kind of a review of everything wind related as far as erosion goes. Talk to you next time. See ya. All right, here we are with some more erosion. This time, let's go ahead and talk about the freezing and thawing process and how ice is able to weather and erode rock away. So let's take a look at this animation. And what you got to understand about ice, okay, is that it's frozen water. Duh, right? We all know that, okay? But the difference is the chemical structure, okay, of ice, how it differs from water is that it's no longer more like a two-dimensional type thing. It forms more of a three-dimensional structure. And when it does that, it goes from this to this, which takes up a lot more space. And you know that if you've ever taken a water bottle and stuck it in the freezer, okay, basically the water bottle bulges outwards because that ice, that three-dimensional structure, takes up more space. Okay, it's more volume. Hence, it's less dense. That's why ice floats on top of the liquid water. But we know that. Okay, so anyway, let's take a look at this piece of rock here. And if we hit play, what we'll notice is going to rain. All right, and then the temperature is going to drop. It starts snowing. That water inside the rock starts to freeze. And what happens is it starts to break it. Now, this water can find all these little tiny crevices in the rock. And when it gets in there and freezes, it widens these crevices. And when this happens over and over and over again, eventually you see there on the animation that the rock finally breaks and then falls due to gravity and moves somewhere else. That's the erosion part, right? The weathering part is the part where the rock actually breaks down. Okay. And that's freezing and thawing of rock. And you can see a picture of a rock up here. And I'm sure you guys have seen this on the streets. This is basically how potholes are formed. So now you know. See you next time. Bye. Okay, it is time to talk about coastal erosion. And we kind of have to understand that the coast erodes because of waves. And how are waves formed? Well, waves are formed by the wind, and the wind is formed by the sun. Wait, what do I mean? Okay, so the sun provides heat energy to the earth, and basically that heat energy creates wind, and this wind blows against the water. Okay. And over a long period of time, the water builds up energy from this wind and it reaches the coast. And that energy is transferred from these waves that were created by the wind to the rocks that are found along the coast that you see here in this animation. All right. So if I play the animation, what you see here is the water waves slamming the coast. And what they end up doing is they end up breaking rock. Okay. They end up weathering this rock. And this rock then forms different structures. Now, what am I talking about? Well, if we replay this, what you understand is that because of this energy, you have certain little holes that form. Okay. Now, these holes start off as sea caves. All right. And these sea caves bust all the way through to the other side, forming a sea arch. Okay. An arch. And these sea arches break down over time because they get higher and higher and higher, and the top gets thinner and thinner and thinner and thinner, and then it caves in, forming what we call a sea stack. So let's go over it real quick. Okay, we have sea caves that form at first, all right, and then they punch through all the way through to form what we call a sea arch. All right, these sea arches get larger, the top collapses to form what we call a sea stack. These C stacks shrink to form a C stump. Eh, what are you going to do? All right. And basically, that's the process of erosion. Remember that. C cave forms a C arch, forms a C stack. And that's the order of erosion on the coastline. Bye. Good night, sweetheart. Well, it's time to go. Do, 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 do. Good night, sweetheart. Well.